In this lesson, we're going to talk about addition reactions. So in organic chemistry, there are different reactions to convert simpler organic molecules into larger, more complex ones. An example here is Taxol, which is an anti-cancer drug that can be synthesized from smaller organic molecules in a lab. So some of the organic reactions that we will talk about are substitution, addition, and elimination. We're going to focus on addition in this lesson. Oxidation and reduction, and condensation and hydrolysis. So addition reactions are reactions that occur between either an alkene or an alkyne and some other smaller molecules, so water, hydrogen, HX, or X2. Benzene, which if you recall is a cyclic alkene where every other bond is a double bond. So a cyclohexene with 3 double bonds, that is not going to undergo addition reactions. So we have 2 compounds that are going to come together, the alkene or alkyne and the small molecule, and we're going to form one larger product. And we may have isomers form, and we'll talk about isomers momentarily. So the small molecules that may be added, common ones are water. So we have, that's going to split into hydrogen and hydroxide as the 2 separate groups that we'll add. Hydrogen and a halide, so either chlorine, bromine, or iodine. So that HX, the X stood for a halogen. X2 or a diatomic halogen, so chlorine, bromine, or iodine. And hydrogen, so splitting into 2 atoms of hydrogen to add on. So in an addition reaction, what's going to happen is the double or triple bond between 2 carbons is going to break, and then each of those carbons is going to need something to bond to as it breaks. So whatever our small molecule is also going to break into the 2 smaller pairs, and one will attach to one carbon and the other pair will attach to the other carbon. So just some general equations here. If I am adding hydrogen to an alkene, then we're going to have hydrogen attached to each carbon that was involved in the double bond. So that one bond there is going to break, and each carbon now has one more thing it's going to be attached to. If we add water, the 2 pairs are going to be hydrogen and hydroxide, and that is going to give us an alcohol for the type of molecule we have. So here, where we were just adding hydrogens, we don't have the double bond anymore if it was an alkene, so this has become an alkane. If we are adding hydrogen with a halide, so a hydrogen will attach to one of the carbons, the halide, so chlorine, bromine, or iodine to the other carbon, and that's going to give us a haloalkane. And if we are adding diatomic halogen, then we are going to have a dihaloalkide. So either 2 chlorines, 2 bromines, or 2 iodines added to what is now an alkane. So if I have hydrobromic acid being added to, this is propene, so we have 3 carbons and a double bond. So this double bond is going to break. The bond between the hydrogen and the bromine is also going to break, and one of those is going to attach to this carbon and the other will attach to the other carbon. So the question here is, why does the bromine add to this carbon and not to the other one? So why do we not have this instead? And these would be 2 different molecules. So if we were to name these, because we have a propane, so this here was propene. Once we add the hydrobromic acid, hydrogen attaches to one carbon and bromine to the other. So in this case, it doesn't matter which end I number from, this is going to be 2-bromopropane. And over here, this is going to be 1-bromopropane. So how do we determine which one happens? So those are called isomers. because they have the exact same chemical formulas. So both of them have 3 carbons and 3, 4, 5, 6, 7 hydrogens and 1 bromine. So 1, 2, 3 carbons, 3, 4, 5, 6, 7 hydrogens, and 1 bromine. So they have the exact same atoms making them up. They have the same chemical formula, but the attachment is not the exact same. So we have different names for those molecules. So those are isomers of each other. So when we have addition reactions, sometimes, depending on what we are adding, we may have isomers, and we'll learn how we figure out which one is the more common isomer that will be formed. So we have another example here, pent-2-ene, and adding hydrochloric acid. So we're going to have the hydrogen and the chlorine are going to attach there to the second and third carbon. So it could attach to the second or the third for the chlorine in terms of the name. So we could have a 3-chloropentane if the chlorine adds to the third carbon, or we could have a 2-chloropentane if it adds to the second carbon. So both of these are going to be products in that addition reaction. But one of those is going to be what we call the major product. So we're going to have a lot more of that product created. And that is going to be based off what is called Markovnikov's rule. So the hydrogen from the small molecule. So this could be if we have an acid with a halogen, or if we have water. So the other ones were either 2 halogens, so a diatomic halogen, or hydrogen, in which case we have the 2 of the same atom being added, which means we won't have isomers there. So these 2 will give us isomers. So the hydrogen in that small molecule is going to attach to the carbon from the double bond that has the most hydrogens already. So over here I have propene again. So these are the 2 carbons in the double bond. That's where that is going to break. So the hydrogen could attach here or here, and then the chlorine could be here or here. So which one's going to happen? So Markovnikov's rule for the major product, so most of the product created will be this isomer. So the hydrogen is going to attach to the carbon that has the most hydrogen. So this carbon is attached to 1 hydrogen right now. This one is attached to 2. So Markovnikov's rule says that the hydrogen from here is going to attach to this carbon because it has more hydrogens. And then the chlorine is going to attach to that carbon over there. So 2-chloropropane is going to be the major product. We would have had some where the chlorine attached to here and the hydrogen attached to here. That would have been 1-chloropropane, and that would be the minor product. So alkynes can also undergo addition reactions. So if we have a 1-to-1 mole ratio, so 1 mole of alkyne to 1 mole of whatever is being added, then that will result in an alkene. So if 1 bond is broken here, then we'll have an alkene, and then once again, it doesn't matter which of the small molecules, all of the same rules from before apply. So we may have some isomers based on if we have either HX or water being added. So if it's X2, a halogen, or hydrogen, then we don't have isomers. We only have 1 product being created. And then if we have more than a 1-to-1 mole ratio, so if I have excess of whatever is being added, so the first step would be for it to become an alkene. And then if I have more of that small molecule, then that will undergo another addition reaction to create an alkane.